Hello, my dear students. How are you all? I am fine. I am Khandakar Fazle Rabbi, lecturer, Department of Chemistry, Milestone College, Uttara. During this pandemic situation, welcome you all to our online chemistry class. My dear students, today we discuss about some important creative question from chemistry first paper, chapter 1, safe use of laboratory. My dear students, this is our first stem. Here given some apparatus that use in laboratory. First one is conical flask, B is pipette, C is burette, and D is volumetric flux. And our first question is, using the glass wire A, how would you prepare a decimolar solution of sulfuric acid? That means, my dear students, here given concentration is equal to 0.1 molar, and the given volume of sulfuric acid is 100 ml. V equal to 100 ml. And my dear students, the molecular mass of sulfuric acid M equal to 98 gram. So, my dear students, we have to determine how much sodium hydroxide is required to prepare 100 ml 0.1 molar solution. Now, what is the value of W? My dear students, we get S equal to W into 1000 divided by mv. So, W equal to S mv by 1000, or W equal to S equal to 0.1, molecular mass M 98, volume 100 ml divided by 1000, or W equal to 0.98 gram. So, my dear students, from the above calculation, it is seen that if we add 0.98 gram sulfuric acid in apparatus A, we will get 100 ml decimolar solution. My dear students, our next question is, what step will be taken to convert the solution of container D mentioned in the stem into decimolar solution? So, my dear students, here given value V1 equal to 250 ml and given concentration S1 equal to 0.15 molar, and our required concentration S2 equal to 0.1 molar, that means decimolar, and the volume will be V2 equal to what? My dear students, we know that V1 S1 equal to V2 S2. So, V2 equal to V1 S1 divided by S2, and V2 equal to value of V1 250 into S1 0.15 divided by 0.1, and volume will be 375 ml. So, my dear students, to prepare decimolar solution, from the container mentioned in the stem, mentioned in the stem, 375 minus 250 equal to 125 ml water will be added more. My dear students, our next question is B, C and D glassware are used in volumetric analysis. Analyze. The given apparatus B, C and D are used for volumetric analysis. By volumetric analysis, we determine the concentration of an unknown solution. Pipette B, burette C and volumetric flux D are used to complete volumetric analysis. B is pipette. It is made of glass and used for measuring and transferring liquid with accuracy. In all pipettes, there is marking using which we can measure a fixed volume. C is burette. There is no alternative of it in volumetric analysis. Standard solution is taken into it, and in titration, drop by drop solution is added from it to determine the end point. And again, D is volumetric flux. Volumetric flux is used in volumetric analysis for preparing standard solution. My dear students, according to this stem, we can also say what is standard solution. Standard solutions are the solutions of knowing concentration, and in container D we use sodium carbonate. Sodium carbonate is primary standard substance, and the solution of sodium carbonate is primary standard solution. The substance which exists in nature as pure state and which is not attacked by the component of air such as carbon dioxide, oxygen, water, and which concentration is remain unchanged by the time are known as primary standard substance. And in container A we use sulfuric acid. Sulfuric acid is secondary standard substance. What is secondary standard substance? The substance which exists in nature as impure state and which is attacked by the component of air such as carbon dioxide, oxygen, water, and which concentration is changed by the time are known as secondary standard substance. My dear students, this is our second stem. Here given nitric acid, sodium hydroxide, and ammonia solution. Our first question is, how are the chemicals storing safely in chemical laboratory? Explain. And our second question is, describe the effect of the chemicals used in laboratory on the health as well as environment, indicating the importance of their safe disposal. My dear students, the safe preservation technique of ammonia solution, nitric acid, and sodium hydroxide. Nitric acid is a strong acid and corrosive, so it should be kept either in glass or ceramic bottle. In no case the bottle should be kept opened, as nitric acid smoke can get mixed with air. Again, water should not be added directly into nitric acid. The solution of ammonia is ammonium hydroxide. Bottles containing ammonium hydroxide should not be kept opened, as ammonia can easily escape the solution as it is volatile. So, ammonium hydroxide should be preserved in a cabinet with sufficient airflow. On the other hand, sodium hydroxide is a strong base and corrosive. It should be preserved in cabinet in lab place under fume hood. The bottle should not be kept opened. Also, sodium hydroxide reacts with glass as forms sodium silicate. So, instead of using glass stopper in bottle, should be use plastic stopper. Our next question is, describe the effect of the chemicals used in laboratory on the health as well as environment, indicating the importance of their safe disposal. My dear students, at first we discuss about nitric acid effect on health. Nitric acid is very oxidizing and very corrosive as acid, affects different organism of body on exposure. Effect on environment. Component of acid rain decreases pH of water and soil, as acid rain affects plant aquatic living system. Sodium hydroxide effects on health. Sodium hydroxide is a strong corrosive agent. Exposure to ice can lead to blindness. Entrance through mouth affects respiratory tract, stomach, and other organisms of the body. Effect on environment. Reacts with sodium hydroxide reacts with aluminum, tin, and zinc and produce hydrogen, which is explosive. Sodium hydroxide dissociates in air to produce sodium oxide, which is harmful to the environment. Now, ammonia solution effect on health. It is a weak base and corrosive. Taken through breathing can cause asthma, bronchitis, harmful to eyes and skin. and effect on environment of ammonia solution pollutes water and affects aquatic life on plant ecosystem. Presence of nitrogen in water causes eutrophication. Excessive ammonia affects plant growth.